In this problem, we're going to have a conjunction of the form P and Q appear. And whenever we see that, we can just replace it by a separate P and Q down below, whether it occurs in the givens or in the goals. So our problem is, prove that if A is a subset of B and A is not a subset of C, then B is also not a subset of C. So let's try and draw a picture. We want to take one set A, and that's supposed to be a subset of another set B. And then we're assuming that A is not a subset of C, so A is not entirely contained in C. So they might have some overlap, but C doesn't contain A. All right. And the important part of that is that there are some elements of A that are not in C, right? So it's this region here that we're interested in. And then the conclusion is supposed to be that B is also not a subset of C. And that's true because these points here are not just in A, they're also in B. Okay, and so they are points in B that are not in C. Of course, B also has a lot of other points out here that are not in C as well. Okay, let's see how we can prove this. Here is our goal, right? We have a conjunction here. And right away, we will do direct proof and move the antecedent over as a given. And now we have this conjunction appearing by itself. And so we can just replace it by those two statements separately. Okay? If we know that A subset of B and A not a subset of C is true, then we know that A is a subset of B is true, and A not a subset of C is also true separately. Okay, and then our goal is to prove this statement that B is not a subset of C, and it's often painful to prove that something is not true, and it's a good situation to try proof by contradiction. So we can bring the negation of that over as a given, that B is a subset of C, and our goal becomes a contradiction. Okay, so we need to work with these givens, and just think about it for a moment. A is a subset of B and B is a subset of C, so it seems by sort of transitivity that A is therefore a subset of C, which contradicts the middle statement. Okay, and that really is what's going on here, but we haven't really proven that about subsets yet, that transitivity, so how about we break it down to the logic and prove it rigorously. So let's write out some definitions. A is a subset of B, B is a subset of C, and then the interesting one, A not a subset of C. Well, that's the negation of A being a subset of C. And we can substitute in the definition of A subset of C right there. And then I want to get rid of this negation sign. I want to sort of push it past some things. So when we move it past the universal quantifier, it turns into an existential quantifier. And then I want to also negate this conditional. Before I do that, I should probably rewrite that conditional as in a different form as a disjunction in this case. Right, this conditional is true if and only if either the antecedent is false or the consequent is true. Okay, so that's equivalent. And now I know how to negate a disjunction. I just flip it over and get a conjunction, and I negate each of the individual statements. So I've gotten rid of my negation sign, and moreover I have an existential statement as a given, so I can do existential instantiation, which will actually give me something to work with. Right? I know that x naught is in A and x naught is not in C. And now I can go back to my universal statements and do universal instantiation for the x value x naught. So I get a conditional and another conditional. And then here I have a modus ponens, right? X naught in A together with the first conditional gives me that x naught is in B. Bring down the one I haven't used yet. And then the first two once again give me modus ponens, x naught in C, and together with x naught not in C from up here, I get my contradiction, and I'm done. So let's write this thing down. First of all, we are proving a conditional statement, so we do direct proof, make the antecedent a given, and actually I'm going to, yeah, never mind. So suppose A is a subset of B, and A is not a subset of C, and our new goal is here. We show that B is also not a subset of C. All right, so then to prove this, we did proof by contradiction. Okay, so we made the negation a given and tried to derive a contradiction. So I will say, suppose for contradiction that B is a subset of C. And then we're over on the given side, and to actually be able to do anything, we had to come up with this X naught somehow, right? Which came from this existential statement, which came somewhere all the way back here from A not being a subset of C. Okay, so that got us there. And then we followed all this down and eventually got our X naught. So let's introduce that new variable. We'll say because A is not a subset of C, there exists some X naught such that X naught is in A and X naught not in C. And then we needed to do universal instantiation to get these two conditionals. And those, well, the one we care about at the moment is that one, so we can do modus ponens. And that one came all the way back here from A being a subset of B, right? The definition of that was that universal statement, and then universal instantiation gets us here. So let's write about that modus ponens, because X naught is in A, and A is a subset of B. It follows that X naught is also in B. And then we did quite a similar thing, right? Now that we have X naught in B, we can combine that with the other conditional by modus ponens to see that X naught is in C. Okay, and this conditional came from B being a subset of C, right? Whose definition was right here, and then universal instantiation got us to the conditional. So another modus ponens to write up, because X naught is in B and B is a subset of C, it follows that X naught is in C. And that's a contradiction, because we already said, right, that X naught is not in C. And so those two together give us the contradiction that we were seeking. I need to say that. So this contradicts the fact that X naught is in fact not in C. And just to sum up my proof by contradiction, I supposed that B was a subset of C. I got a contradiction. So say therefore B is not a subset of C. And that was my goal. So I'm done.